Hi, welcome. My name is Daniel Chakev, and today we'll talk about DuckDB and the rise of single-node processing engines. And my talk consists of two parts. In the first part, I will talk why DuckDB is so popular and why you should care about it and why it's so fast. And in the second part, I will talk about the project where we use DuckDB, why we started to use DuckDB, and how we use this. And throughout my presentation, I will also emphasize the importance of relational data processing and SQL. And before we start, let me introduce who we are. We are a mid-sized IT consulting company. We have expertise in software and data engineering and data analytics. And we have a major partner. We have partnership with major platform and cloud vendors. One of them is Database. Before let me also recap or start the part one and recap some terms. Firstly, what is OLAP? Because I will talk about a lot about OLAP, online analytical processing. Its typical application is data warehouse reporting or dashboarding. We have a lot of read transaction, fewer long-running write transactions, a lot of aggregations, and a typical represented Snowflake or DuckDB. So secondly, I will use throughout my presentation an example, and we can think of it's a fictional fashion retailer, and we have the following sales data. It's already mapped to, for example, we have a sales transactions, where we sell our items, fashion items, and they already mapped, the transaction timestamps already mapped to transaction day. And what we, for example, if you're a data analyst and in a fashion retail company, it could be that your company has started a marketing campaign, and now you want to analyze how well your marketing campaign performs. And what you can do, for example, is to compute daily aggregates for category and then compare it with the same time period from the last year. And then you can see how well performs your marketing campaign. And how would you typically do it? If you have, for example, an OLAP processing engine or you have a data warehouse, you can run a SQL query. So now we're back to the SQL and relational data processing. And thirdly, I would like to briefly introduce what actually DuckDB is. It is a single file in-process OLAP database. And I think that for me personally, the best term that describes DuckDB is pocket-sized Snowflake or SQL OLAP SQLite. And if you're a heavy Python user, have a Python developer, in order to start with DuckDB, you only what you need is to pip install DuckDB, and now you can process. In this example, it's the same query from the previous slides. Now you can process larger than memory Parquet files in this example, and process your analytical query.
I see the actual file for everyone. If you leave this open, or is the noise from outside somehow disturbing how well you can listen, or can you think it's fine? Okay.
Well, yeah, please take a seat. I hope also that the font size is large enough that you can read. Sorry, maybe it's due to the font size.
See.
And before I dive into what led to the popularity and what led to the popularity of DuckDB and why DuckDB is so fast, this is brief takeaways and brief summary from the next slides. And why, from my opinion, is DuckDB so popular? It uses a user-friendly programming interface. Relation model is the foundation for DuckDB, what they use. It's use so-called vectorized column-based push processing model. I will try to explain what it is. And it's database file organized like a Parquet file. And it has a high interoperability with different data processing libraries and also different file formats and lakehouse formats, for example, Delta or iSpark. So let's dive into what led to the popularity of the DuckDB, and let's recap what happened in the data processing community last 2 decades. And starting from I think from the beginning of 90s till mid 2000s, the data warehouse market was fully dominated by companies such as Teradata, where they offered data warehouse software for highly specialized hardware at a high cost. And this was disrupted by Google researchers and Google engineers when they published how they described in their publication how they managed to build their inverted file indices on a large-scale data using commodity hardware and shared nothing architecture at low cost. And open source community implemented the ideas, and this is how the Hadoop framework, Apache Hadoop framework was born. And the beauty at that time was that as a developer, if you wanted to develop an analytical processing pipeline, you only needed to focus on developing a sequence of MapReduce steps. I won't dive into details of MapReduce, but it meant for the illustration purpose. I hope I will convey my idea why. And already at that time, the data processing community realized that MapReduce and Hadoop framework was not flawless. And there are at least three points that could be improved. The first one is not user-friendly programming interface. The second one is processing speed. And the third one is the lack of transactions. So let's look how the interface looked at that time. So if you wanted to write the query from the previous slides, you needed to write a map step and reduce step to solve the problem, to solve our analytical processing problem. And at that time, as a data analyst, a data scientist, you had two choices: either to learn Java and try to understand how the MapReduce work, or you need to hire or go to your software engineer, ask him to write such programs. But actually, what you wanted to do is to do like this: to write your program in declarative manner, so you can write your analytical query. So, and this was main motivation for the Facebook engineers to develop Apache High framework, where now using Apache framework, you could now translate your SQL queries into a series of MapReduce steps. So now we're back in our SQL world and relational world. So now the second major point of improvement is that processing speed of MapReduce. The main problem is that if you write a sequence of MapReduce steps, after each step you will write the data to the disk and read the data through the disk. At that time, it was justified because you wanted to process a big amount of data using distributed computing. So you had different nodes, and if something went wrong, you can use the intermediate results, and this would increase your robustness of your program. However, we still have a big gap between processing speed on the disk and SSD, and between SSD and even between SSD and even between RAM. It's we can calculate it's about a factor 5,000. And what is the answer to this? How we could do it better? So on the other hand, we can, as MapReduce does, we can materialize our intermediate results, or we can do it like a conventional relational databases do it. So starting from mid-90s till, I think, mid-2000s, this is the way how normal or conventional databases, relational databases, processing the data. It's so-called pipelining. So we can use pipelining techniques. So if you write an SQL query, it's translated into a series of relational operators, and each operator fetches one tuple at a time. From the software engineering perspective, it's like an iterator concept. So in this case, and in that time, the main memory was small, and the whole pipeline was dominated by the time of the processing was dominated by the time reading data from the disk. That's why you wanted to reduce the number of IOs and to use main memory more efficiently. And this is also was one of the main ideas of Apache Spark framework, and what they develop, and they address the Hadoop input-output bottleneck. Secondly, firstly, they introduced a functional light programming interface. In 2014, they introduced SQL as a primary programming interface to work with your data. So the main idea is to process as much in memory and use pipelining to reduce the number of IOs. So, meanwhile, in the last 2 decades, also the hardware changed. We have major hardware improvements. Now we have also in the commodity hardware, we have CPUs with up to 16 cores. Caches is increased, cache size is increased, RAM is increased. Also, the single instruction multiple data register is increased. So now we can take advantage of new hardware and how it's actually does data community or databases, conventional databases. The first answer is to use, instead of processing one tuple at a time, we're processing a batch of tuples. And this would increase cache locality and increase the speed of the processing. And it is we can do it also better if we know that we are using OLAP processing. So since we have an OLAP workflow, we have a lot of aggregates, and we have typically we access the data. We are only interested in the queries on a subset of columns. That's why the way how the data is structured in main memory or on disk also impacts the performance, and also benefits from the hardware, for example, from SIMD registers. So they're aligning the data to cache sizes and to register sizes will reduce the computation time. One also possibility, since we have multi-core processors, is to, instead of pulling the data, we can push the data. This would decouple the communication between the each operators, and this would allow better possibility to parallelize the query. But there is so you have either pull-based or push-based approach. They have pros and cons, and it's a common agreement that for some of the operation, push-based approach is more favorable than the pull-based, and vice versa. and was mentioning these two open source libraries, Apache Spark and Apache Arrow. Apache Spark addresses the problem of column-based organization of data on the disk, and Apache Arrow addresses the column-based organization or vectorized organization of data in the main memory. Let's recap Apache Spark. Apache Spark organizes files into so-called row groups, and each row group is then organized as a series of arrays or chunks that represents each column separately. And as I said, it allows you, this type of storage allows you to, if you want to access only a subset of columns, then you can read only this subset, which will increase your I/O throughput and increase your speed. And additionally, this organization allows you some lightweight compression to use on there if you store these chunks of arrays. Sorry, I won't dive into details. It's a very interesting topic how they apply different lightweight compression or so-called encoding and compression to these columns. Additionally, this would allow to store additional information and statistics about your columns, and for example, min and max values, so that you can efficiently skip the data on reading. So it also will reduce the amount of data that you will transfer from the disk into main memory. Because, as I said before, the reading from the disk is very expensive. Still, 2025, the factor is the difference between reading from the main memory or transferring from memory in CPU caches is faster than reading even from SSD. Apache Arrow addresses the problem for the main memory, and the main idea was and main motivation was to provide a library to work with main memory batch representation for vectorized formats. And nowadays it's grew to a large ecosystem. They provide not only utilities to work with batch data, but also provide utilities and how to access this data or interconnect different systems so that they can pass between the system data, vectorized data. And so now to complete the picture, now we have 2025. We have, on one hand, a lot of different OLAP distributive massive parallel processing OLAP engines. On the other hand, we have a single node processing engines like DuckDB. And what they have in common is that they use as a primary model that they use is relational model. As a primary programming interface is SQL. And secondly, the way how they process data is either push-based or pull-based, vectorized. They process vectorized chunk data. So here's some recap from all the slides that we've seen before, and maybe one additional side note. It's that open source could be an innovation driver based on public and private research. So this was the part one. Okay. So let's dive why we started to use DuckDB and Arrow in our project and how we use it. So my personal journey with DuckDB started 2023. One of my customers has a typical data engineering pipeline where they get data from different sources. It is financial data, time series data, and this is not a real-time or near real-time processing. It's typical batch processing. So what they do, they receive a data set, it undergoes different enriching and mapping steps and validating steps, and then the data set is exposed to the data scientists and data analysts so that they can work with the data. And what the previous version of this pipeline of this application was developed in Apache Spark using Java and Scala. And the main motivation to migrate or to use the system was that I tried to illustrate it with this graph. The most of the data was less than 1 gigabyte. So the most files of the sizes was between 100 MB and 600 MBs. So and additionally, the company was Python-centric, and there were lack of Spark knowledge and DevOps knowledge to run the clusters and manage the Spark clusters. And at the beginning of the project, we looked for, based on their requirements, for a lightweight minimalistic approach. We benchmarked for their application DuckDB, Arrow, Polars, Pandas, and also native Python. And the best fit at that time was combination of DuckDB and Arrow. Now the application looks now, it's a very simplified architecture. So now we run our DuckDB application containers. They fetch, the whole architecture is event-driven. So the container got an event. So there is a new data. It fetches the data. The data undergoes all the data engineering pipeline step. And by the way, I forgot to mention that we use DuckDB as a pipelining tool and using as a database for store metadata. And then the final results of the processing then put back either into distributed storage or into data warehouse. Maybe some key points that how we use this. It's actually a Python application, but 90% of code is SQL, which is templated, and Python is used only as calling the function, which then templates, takes the right SQL templates and runs this. Heavy lifting is done by DuckDB. Sometimes we fall back to Apache Arrow because we need sometimes order preserving chunking of the input files. And sometimes we indeed have files which are they are more than 50 gigabytes in size, 50, 70 gigabytes. And in this case, in order to process in the single node, what we do, that's what actually Spark can do for us. But in that case, it's not, we don't have strict time constraint. So what we do, we chunk the data and process them with DuckDB. And for chunking, we use Arrow. We also use a lot extended data types like map, array, structs for different processing step, and apply high order functions so that the amount of Python code is then also minimized, because a lot of work we can do now using SQL. We also use DuckDB in the client application, so the data scientists can now also run ad hoc queries. So they preload the data, and then now they can using their Jupyter notebooks DuckDB and analyze the data. And in overall, we observed increased throughput. We can process a lot more files at one time. And for this project, the main goal was to improve the maintainability, and so that the developer now, since they are Python-centric and SQL, so they do not need an extra knowledge for running Spark cluster and working with Spark. So maybe one aspect to be aware of, DuckDB is a single file in-process database. Sometimes we expose metadata in a DuckDB file. So if you want to access DuckDB from different processes, you can do it only in read-only mode. But actually what you can do if you want to access with different users, you can write, here's a simplified architecture. If you write your own server, which runs in the same process, runs DuckDB, and then you can access the same file. And you can use it, for example, Aeroflight SQL. This is a special protocol offered by Arrow library, or you can write your own HTTP or gRPC, whatever you like to, whatever you prefer, your preferred framework to write a client-server application. So there are additional some facts about DuckDB. Maybe one worth mentioning fact is the excellent docs. It's really yeah. I just wanted to stress this out because it's I think it's one of the best docs that I observed in the recent years. And so you have also different extensions that's meant to be extendable, so you can write your extensions. And I think that's all from my side. I think I am on time. And
let me finish.
No problem. Yeah, go ahead.
Not prepared.
Oh, yeah.